Alrighty. So for question number 1, we have a mass on a spring. Okay, we're told the mass, so we know what that is. It's 1.3 kilograms. We know the maximum speed of the mass, okay, is 1.4 meters per second, and it has a spring constant of 3.4 newtons per meter. We're looking for what is x, okay, we'll say x final, when it's moving at, okay, 0.65 meters per second. All right, so the object is oscillating, and I'm asked about 2 different points. What kind of question is it? It's a conservation of energy question. All right, so it's a mass on a spring, conservation of energy question. So give them 1 for their givens. Okay, and they can have a mark for identifying that it was a conservation of energy question. Okay, and we'll say that in this case, our initial energy is all kinetic because they told us the maximum speed. All right, so we know that happens at equilibrium where x is 0. Okay, then the other point they're talking about is a point where it has both. It has some potential, and they want us to find the displacement when it's moving at 0.65 meters per second. Right, so that's the information I have. I need to solve for the final displacement. So first thing, so we'll give them a mark if they've got that step. Then we'll start moving things around. I'm going to subtract this kinetic energy over here. So I'm going to have 1/2 mv max squared minus 1/2 mvf squared equals 1/2 kx squared. I'm trying to get x by itself, so I'm going to divide both sides by half of k. In fact, the halves are all going to cancel off. I can just get rid of them, okay, and divide by k. And then I'm going to square root. All right, so we should have something like this for our final manipulation, and that is that x equals the square root of mv max squared minus mvf squared divided by k. So they can have a mark for that. That's their third mark. Okay, we'll say fourth mark is for plugging in numbers. So that'll be 1.3 times 1.4 squared minus 1.3 times 0.65 squared divided by 3.4. Okay, so they can have a mark for that, and that'll tell us that x, okay, so 1.3 times 1.4 squared minus 1.3 times 0.65 squared, and then divide by 3.4, and then square root. Okay, so we're looking at a displacement of 0.77 meters. Okay, everybody all right with that one? All right, so just law of conservation of energy. Okay, we have one position where it only had kinetic and the other position it had both. Okay, number 2, similar, except it's a pendulum. What kind of potential energy does a pendulum have? It has gravitational potential energy. All right, so here's what we know. We know that the amplitude, okay, or the maximum height, I'm just going to call that h initial, okay, is 0.30 meters. Okay, and I'm looking for the pendulum when it's at its final height, the speed of the pendulum that is, when it's at a final height of 0.17 meters, I'm looking for VF. So 1 mark for givens, 1 mark for law of conservation of energy. Okay, and we are looking at m times g times h initial equals m times g times h final plus 1/2 mv final squared. Okay, it's just conservation of gravitational energy with a pendulum. All right, so we're trying to find VF, so we're going to subtract MGHF over here. We're going to cancel all the M's, so we'll have GHI minus GHF divided by 1/2 square rooted to get VF. Give them a mark for that. Okay, numbers plugged in, 9.81 times 0.3 minus 9.81 times 0.17 divided by 1/2. So mark, sorry for that step. All right, so we're looking at a speed here of 1.6 meters per second. Okay, so judging from the questions I got about this, the second question threw people. Okay, so just let's be aware that a pendulum is also something that is simple harmonic motion, but can still exhibit the conservation of mechanical energy, right? It's just like a roller coaster. Okay, if I'd have said a roller coaster, blah blah blah, you guys would have done this right away. Okay, it would have been because that's a context you're familiar with. Okay, so just be ready. Sometimes I'm going to throw a different context at you and see if you can apply what you know to this kind of new situation. All right. Okay, so give him a mark out of 10. Okay, let him see it and just bring him up to me.